Good morning, all of you. Okay, I can see still election fever, right? In our team. Very good. Okay, guys, so please focus. Today class is very important. So, am I audible, guys? Online team. Projector. Yeah. So, guys, what is horizontal pod auto scaling YAML? Okay. What is horizontal pod auto scaling YAML? In Thursday class we discussed, right? Or when Friday class. What it does? What it does to scale up, scale down the pods. Okay, like a auto scaling group. Scale up, scale down the pods. Anyway, let me connect the server first. Which mission? Okay, so my cluster is already running. Okay, so the first command kubectl get nodes. So I can see my nodes. How many nodes are there? Two nodes. Two nodes. So what I can do now, I think already we discussed how to give pod access to external, right? External access by using load balancer or node port. So first we need to deploy the pod.ml, if it is a pod.ml, and we can give the access to public by using service.ml. So how your service.ml link with pod.ml or deployment.ml? By using labels, by using labels. Okay. So yeah. So what I can do now, if you can see my end, okay, cd Kubernetes 9 a.m. Okay, and if you can go for day 2, ls. So pod.ml. So guys, let me check any pods are there. What is the command to check? Kubectl get pods. So one pod is running. So if I want to delete this pod, how to delete? Kubectl delete pod and pod name. How to delete the pod? Just copy it, paste it, and delete it, right? And delete it. Now again, kubectl get pods. Again, pod is created. Again, pod is created. Why? So, anyone? Very good. So let me check. Okay, kubectl delete. I will tell you everything. Don't worry. Deleted. So guys, we need to understand one thing. If I go for ls, so vi pod.ml. So if you can see this is the pod.ml. The pod contains what, guys? Inside pod, what it will be there? Image and container and image. If you can see, this is my container. Name is Nginx container. Containers come from this image. These containers come from this pod. I mean, inside pod, container, containers inside image. Is this clear, right? So if you can see guys, my pod.yaml kubectl, I'm going to run my pod.yaml kubectl apply -nef pod.yaml. I mean, I just created a pod. Again, pod create means it is created from image and container. So application is running. So I can give access by using service.yaml. So guys, if I give kubectl get pods, my pod is running. My pod name is what? My app. See if you can see. My pod name is my app. So the pod name comes under metadata section. Metadata section. These labels will help. These labels will not help to run your pod. Understand? This labels is an optional one. If I create any service to give access for this pod, only these labels will help. Until and that labels not required to create a pod. Clear? Yeah. Let's go to again kubectl get pod. So if you can see my pod is running, right? How to delete this pod? Kubectl delete pod my app. Guess you can start the practice on Minikube for one day at least to practice these commands. Okay, to practice the commands, no need to create a cluster. Just I'm saying that only. Otherwise, yes, I'm free now today. I can work at least 6 to 7 hours or 5 to 6 hours. In that case, only create a cluster. For 15 minutes work, 10 minutes work, don't create a cluster. To create a cluster, 20 minutes time will take. To delete a cluster, 20 minutes time will take. You can do work for only 10 minutes. Is there any use? So don't create cluster if you are busy. Leave it. Do practice on Minikube. Minikube installation process and everything is there. I will show you if required here also. Okay. I mean, commands process, I'm saying that. Commands process, you can practice Minikube. Once you clear how to delete, how to create. So if you are clear means go for cluster directly. And that time also, if you are able to invest your time at least 5 to 6 hours, only go for cluster. For 15 minutes task, 10 minutes task, don't create clusters. Okay. You need to practice projects. You need to do projects also, right? So at least you need to, make the account is live. So if you can see guys, if I delete my pod is deleted, right? Tell me guys, if I give kubectl get pods, what is the result? Pod will be there or not? Pod will be there or not? Pod is running, I have deleted. Again, pod will create or not? Same place. Create or not again pod? Tell me immediately. We don't have time. Self-healing. Self-healing means create pod, right? Okay, check here. No pod, right? The reason you created a pod.yaml. Pod.yaml will not give any self-healing. The reason, if you can see here, is there any replica set? No, we are not saying how many pods are required. So pod.yaml will not help for us to create how many replicas to maintain it. Understand? So self-healing not possible from the pod. That's what we are not using pod.yaml for your real-time environment. Is this clear? Okay. Yeah. Now go for again ls. So we have a deployment at YAML, right? We have a deployment at YAML. Go for VA deployment at YAML. See guys, if I create a deployment at YAML, what happened? How many pods will create? 3 pods. 3 pods. Pods can create from this image and this container, and container port is 80. I will show you what is ports and all everything today class. So now if I deploy, guys, already all YAML files I have explained Thursday class. Okay. Please don't create any suspense here. Sir, what is deployment data and like that? kubectl, how to apply this deployment data? kubectl apply -f deployment.aml. So my end, no pods are running, right? If I apply, how many pods will run? 3 pods. How to check? kubectl get pods. 3 pods are running, right? Now container is creating, it will take some time. We'll plan all troubleshoot in one class in pod troubleshoots. What kind of issues we can face. So 3 pods are running right now. 3 pods are running. Now tell me guys, if I delete one pod, kubectl, how to delete? Delete pod, any one of the pod. These are the names of the pods. So you can give any name of the pod. Deleted, right? Now if you can give get pods, how many pods will be there? 3 or 2. Online team, 3 or 2? 3. Three pods. See, if you can see which one is the new one? Last one, 17 seconds. See, it created PXS2F new pod. So self-healing work here. The reason, if you can go for VI deployment.aml, see, replicas 3 means always should maintain 3 replicas like a desired. In your auto scaling group, there is a desired option, right? If you can give desired option, whatever load is there, first will create a desired set point, 2 or 3. So this will work like a desired, not a minimum maximum. Understand this point. That's what if you delete or see guys, my load is more. For example, 3 pods are not sufficient. 4th one will require. It will not help. It will not help. What I can do? Go to deployment. I can change simply to 4. But what you need to do again? You need to apply the changes, right? You need to apply the changes. kubectl apply. Now you can see configure. Nothing, there is no changes means no changes will come. But configure means yes, changes will be there. Now you can give kubectl get pods. See, 4 pods are running now. I mean, is this static or dynamic approach? Static. You need to check the load and then change the set point. But you need to automate the process, dynamic the process. So in that case, definitely we need some reference files. What is the load? Understand what is the load and all. So, and the same thing guys, go for ls. We have a replica set, right? We have a replica set. VI replica set. Same process like a deployment, no changes. Replica set, deployment.aml, no changes. Only kind will change. That's it. But what is the difference here? What is the difference here? Deployment.aml will support some rollback options. I will show you what is the rollbacks in coming classes. The rollbacks means, for example, if you upgrade your version, okay, if you upgrade a version, without downtime of your application, you can upgrade the version of your pods. But that feature replica set will not support. That's what real-time replica set we are not using. Is this clear? So we are going to use only deployment.aml always in the real time. Clear? I think if you want to run, okay, let me run this one also better. So kubectl apply -f replica set.aml. How many pods will create? Same like a deployment, no changes. If you delete one pod, immediately one more pod will create. Why? There is a replicas. So replicas means it will give a self-healing process. Self-healing process means controller will monitor. If any pod will be deleted, immediately worker node kubelet will tell to API, one pod is deleted, API will inform to controller. So create one more pod again. You need to maintain desired state and current state like a Terraform state file, right? It will be created immediately. If I give kubectl get pods, see, I can see now 7. I mean, 1 is for created by using pod, and 3 are created by using deployment.ml. 3 are created by using replicas.ml. Clear? Now, guys, if you want to delete entire pods, if you create pods, immediately pods will create it, right? Same like auto scaling group. In auto scaling group, if you create one instance, immediately auto scaling group create one more instance. So what I need to do, delete the deployment, delete the replica set, then only you can control. Understand? So how to delete the replica set? kubectl, yes, delete replica set or rs, shortcut is rs. Give the replica set name. Sir, we don't know replica set name. What I can do? kubectl get rs. If you want to know the information, get command. If you want to delete the information, delete command. If you want to apply the information, apply command. Only 3 commands in Kubernetes. No need to learn 100 commands. Only 3 commands. Apply, delete, get. And 2 more commands are there. -o wide, describe. 5 commands enough for Kubernetes. Okay. So kubectl get rs. I mean, I want to know my replica set YAML file. So this is the replica set name. Okay. Okay. So now if I want to delete this 4, these 3, how can I give? kubectl delete rs, give the name. And you can do one thing also. Deleted. Now check the kubectl get pods. So this time only deployment related information is only there. So you can do one thing. You have a YAML file, right? See, you have a YAML file, replica set. You can delete by using YAML file also. How to delete? So delete 2 options. Check the name, give the name to delete, or directly give to delete by using YAML file also. For example, my deployment data I'm already running, right? So what I'm going to do, kubectl delete -f, same in place of apply, delete will come. Give the deployment.yaml file. Deployment YAML will be deleted, means interpods will be deleted. Now kubectl get pod. Okay. Pod already earlier we have deleted. So no pods are running. Understand the difference? The replica set and deployment and pod. No restart. What you can restart here? In Docker, if you want to check the container, what is the command? Docker ps or Docker container ls also we can give. Here, get pods, kubectl get pods. What is the difference? Yeah. So Vinay, very good question. Anyway, let's go for my paint in that case. So the difference of the deployment and replica set, and we have a one more thing, replica control also. That one is deprecated already. If an interview asks, no one can ask. If they ask, the only difference is replica control is a deprecated one we are not using. So replica control will not support for multiple options inside the YAML file. For example, okay, I will show you here better. So guys, replica set and deployment data. Leave for replica control we are not using. Sorry, deployment. Okay, guys. So deployment and replica set. What is the difference? So the difference is we can easily understand, guys. By using the replica set, if you create a 3 pods, if you create a 3 pods. So in the replica set, in the YAML file, replica equal to 3 means definitely 3 pods will create. Okay, 3 pods will create. Here also replica equal to 3 means here also 3 pod. Then what is the difference? That is the question. So guys, just take a simple Nginx web server. Guys, this Nginx server, the version is, for example, 1.6 you have deployed. Okay, this Nginx 1.6 you have deployed. So inside some application is running Nginx application. In your case, your project application also, whatever it is. Now you need to upgrade to 1.7 version due to some new features. Okay, what you need to do? You should not delete and recreate. Delete and recreate, no use. There is no high availability. So there is no use. So what I can do, I can roll up or roll back. Roll up means it will go for next version. Roll back means previous version. So 1.6 version to you need to change 1.7 version. So definitely to delete recreate means it's a replica set or deployment, both are same. No problem. But it is not like that. We should not down the application. We can increase the version only. So we can increase the version, we can decrease the version by using rollback concepts, rolling updates. By using rolling updates. So this rolling updates will support only for deployment.ml. This rolling updates will not support for replica sets. Okay. Simple answer is we cannot enable rolling updates on replica set. Okay. So we can do it the rolling updates into deployment.ml. Is this clear? So you should stick on, if you go for replica set, the pod version, you should stick on that, your application version. Okay, if you go for replica set, if you want to upgrade, there is no way to upgrade. You should delete and recreate. That's what replica set is not recommended. Clear? But in deployment.ml, we have so many features. Yes, we have a rolling updates, it will support. If you ask me to show you the rolling update just for so if you go for full stack project, so for example in the Kubernetes in the front end.ml, okay, here there is no rolling update. Okay, anyway, okay, let's go for other project. Is there any? Application front end deployment.ml. Yeah, if you can see, there is a rolling update strategy. So this rolling update strategy will not support for replica set type. It will support for only deployment. If you can take this block type rolling update, if you can add in replica set, it will not create a file since replica set will not support this rolling updates block. Okay, sir, what is 25%? We can discuss later. Okay, this 25% means instead of down all the applications first, we can down the one pod and upgrade the version. 4 pods will be there, for example. Remaining 3 will work previous version. First pod will increase the new version. Like that, we can modify. There is a special class to update how to upgrade the versions. Okay, don't worry on that. Let's go for the practice again. So any questions? Difference between replica set, pod, and deployment.ml? So you will get questions on Kubernetes also scenario based only. May I can ask like, so my pod is running, self-healing is not achieving this pod. So what kind of deployment I have followed? So options, pod.ml, deployment.ml, replicas.ml, all of the above. Our people, all of the above is there means first option is go for all of the above. I've seen many test papers, wantedly have given all of the above options. All 90% people given all of the above answers. I don't know. Anyone? Yeah, I will show. Wait, Nagaraj, I will show that one also. So anyone is there 80 out 80 out, sorry, 40 out of 40? Anyone? 38, 35? Anyone? 30? 30. Okay. 20? All failed, huh? So 21. So this is the honestness. I like this kind of things. Anyway, see, whatever happen is happen again. We can start learning again Terraform. Okay. So what you can do, so after complete this training, you just give 10 days for Terraform, 5 days for Docker, 5 days for Kubernetes. Like that you can plan one calendar. Okay. And start the learning. Okay. Anyway, paper is difficult. Yes, paper is difficult. I can agree that. I told you many times, right? Don't expect paper like Naresh is conducting kind of Terraform exam. No use, guys. See, so the Naresh intention is different. At least they want to give some that special training for more people, not for if they give like kind of paper. If filter maybe if I apply filter, maybe 5 or 6 students will come. How what they can provide again training for 5 6 job readiness program. It's very difficult, right? That's what maybe the paper is very easy. But if you learn in this way, definitely will get a job. No one can stop that. Mark my words. If you learn kind of that, even as I said, my friends also, I shared the paper. They are also saying same thing. Little difficult. Yes, they are also saying that the paper is little compared to certification exam. So if you prepare like that way, you can understand no one can stop your job. What about Git? Is it easy? That's what Git paper I have given little easy, guys. Seriously saying that. I just added 5 questions again, remove the 5 questions. Why unnecessarily? Maybe their confidence level is very important. That's what. Okay. What about next weekend? Which test? Linux. Linux already given 3 questions. That's it. Okay. Ansible. Okay. What I'm planning this weekend, no exam. I will plan for one workshop, any one project. Okay. Take some gap for test series 1 week. Okay. If anyone had to complete, still you have a time complete. So no trainer will give these many days for one exam, guys. Please understand. Weeks of the time. Okay. Okay. So guys, if you can see here, LS. So my replicas.ml, deployment.ml, pod.ml. Very clear, right? No questions on this, right? So now if I want to give any one of the pod access to public, how to give? We have to create a service.ml. Okay. LS. Let's go to service. If you can see here, cluster IP.ml, load balancer.ml, node port.ml. Three ways we have. If I go for node port.ml, so this time not a pod, this time deployment, even whatever it is, Our service will communicate through labels only, not for deployment, not for replica set, not for pod, right? So service is required matching labels. Service is required matching labels. In our paint, I have explained, right, to map this label to this label. So here, if you can see, this is my deployment.yml. This is my deployment.yml. If I create, first one deployment will create. This service YAML you can create here or separate file also, no problem. If you add your service YAML inside your deployment.yml, you should give 3 lines and write the service.yml. If you want to write one more any YAML, you should give the 3 lines and start the one more YAML. Clear? And very important thing, the key names, these are the key names. It should be in the blue color in the left hand, right? For example, give an insert. If you can give like this. Sorry. Let me. Okay. So if you can see here, give insert. So yeah, replicas. See, like this means it will not work. Indentation. So the replicas left hand side is white color, right? So you should give some space. Key name and value of the name 3. In your case, you will get an error. Unable to convert JSON to YAML, parse kind of error you will get. So immediately you can check the spaces here. Okay. Yeah. So here, okay, this is my deployment.yml. This is my service.yml. Okay. So, and which label my service.yml is going to communicate? My app node port. My app node port. This is the selector of this block only select your deployment.yml. So in that case, in my deployment.yml, definitely this app label should be there. Otherwise, service will not link with your deployment.yml. So if you can see app, my app, np is there, right? And here also there. So you need to understand one thing, guys. This is for label to map your service. This is for your service label. You can give any name. This service label to call one more service for this deployment.yml. Understand? So if you have any confusions, better to give same name here and here. No problem. Okay. This is node port. If you can go for load balance, same. Everything is same. Just in place of node port, load balancer will come. That's it, the difference. Clear? And VA, what is cluster IP? Internal communication. So no node port, no load balancer. If you want to give access to external only, you should give load balancer or node port. In this case, see cluster IP only there. There is no node port and load balancer. This is for internal communications. How it will be communicated and everything we can discuss in the coming classes. So our understanding is we have a 3 type of service.yml. One is for cluster IP, one is for node port, one is for load balancer. So anyway, yesterday we discussed node port, right? Today we'll discuss load balancer type. Okay. So what I can do, kubectl, apply -f, load balancer.yml. This name is for just understanding only. Inside deployment dot is there, service.yml is there. Sorry. Now service is, see here, service is created, deployment is created. Inside my YAML, 2 YAML files are there. One is for deployment, one is for service. So in this case, definitely my service also created. My type of the service is what? Load balancer. So how to check the service details here? Command is what? Kubes service, not load balancer. Get SVC. kubectl get SVC. See, type is now load balancer. So we are able to see load balancer URL here. Load balancer created already. So my cluster is in Mumbai region, right? If I go to Mumbai region EC2, My cluster is in Mumbai region. So if I go for load balancer, yeah. Anyway, my end multiple load balancers are there. So what I can do, check the timing. So time is now. Let me refresh. Mumbai region. Okay, what I can do, see, it should be create AP South one only. Maybe it will update after some time. Take this and access here. So we can able to access our Nginx application. Same like node port. Node port means by default, provider will give you the range of port 30,000 to 32,650 something. You can get any one of the port in between. No, if you want to define your port in the node port, you can mention your port number also. But no need, guys. Okay. Even in the real time, we are not using node port. We are using only load balancer. Is this clear? So let's check AP South 1 ELB. Why ELB is not created? It should be created. That's what we can see there only. 957. Maybe it will update after some time. AP South 1. Yes, Mumbai only. Yes, clear service, deploymented AMLs. We have a mainly three types. Services mainly three types. Now, okay, we'll see after some time. Maybe it is loading now. So now we can understand one very important thing. Okay, it is maybe it will take time. Even load balance is exposing the IP, na, sir. Guys, is there any IP? Load balancer is a service, guys. It will not expose any IP, first of all. You cannot log in load balancer to hack your application. It's a service. So very secure. Even we should not give load balancer URL also to outside. What we can do? Create a Route 53 record, give this load balancer URL, map your required domain name. Understand? In the project, I will show you. Yeah. Okay. So let's start now. Okay. LS. So I'm going to kubectl delete -f load balance. Like this, I can delete. Or you create a deployment or service. Deployment, right? You can create, you can get the deployment.yaml file name. You can delete like this also. So for example, two ways. kubectl get deploy. You will get the deployment details. Delete the deployment, not for pod. If you delete the pod, again one more pod will create. So kubectl delete deploy, give the deployment.yaml. This is the one way of deletion. Or other way of the deletion, directly check the YAML file. Instead of apply, you can give the delete. It will delete deployment.yaml. Two ways, okay? Now no pods. The reason you have deleted indirectly load auto scaling group. You need to understand like that. Clear? So guys, kubectl get nodes. My end is two nodes, okay? Clear? Service, deployment, how to create, how to delete and all, self-healing process and all. Okay. For LB, also, we need to add port in security group. Yes, LBLs, it will take from the your work node security group configuration. That is taking care by Kubernetes. No need to take by you and okay. So guys, actually in our node, I mean Kubernetes node, if you're giving node port access, we should enable node port number. Okay. If you create a load balancer, it will take while creating time cluster security group. I mean node security group. Okay. In that case, it can access directly. Okay. If it will not work, you can check your configuration in the network. But by default, it will be accessible. And the next one is dynamic approach. Okay. So far we discussed static approach. I mean replicas changing statically. So how we can achieve by using dynamically? Same like our auto scaling group. Whenever traffic will move, it can increase the load. I mean, increase the count of containers. Guys, don't confuse here. Let's show you here. Don't confuse with this name. For understanding only I have just written. So go for, see what you need to understand. Till here you are clear. Deployment at YAML only, as we know. If I want to give access for this deployment at YAML created pods, we need to write a service file. What is the main agent of the service file? You need to map the labels. Then only service can understand, link with your deployment.yaml. How to map the labels? This is the condition. Okay. Ports, just leave it. I will discuss. And type is what? Load balancer means load balancer. Node port means node port. And metadata is information related to name and your service labels. This is service labels like a deployment labels. This is other services just for understanding. Other service want to communicate this service. Other service target and selector and need to write these labels. This labels is to communicate. This is the source and next is target kind of thing. Now this is the target, right? This is the target. This is the source communication. In that case, in the target end, I need to add the source label. Understand? For example, this is the source. One more target is coming. In the target end, I need to mention which labels? Source labels means these service labels. In that case, it will come into the picture. Now, this is the source. That's what I'm going to add these labels into this target. Now, one more service is call to this service means these labels need to write in their target. Understand? So here, if you mention these labels are not, no problem, service will create. This is for metadata of your service only. But the important one is selector. You have to define your deployment labels, metadata labels. Clear? Yeah. Okay. Same thing apply for node port also. Node port in the place of load balancer, only node port will come. Everything is same. You can write service different service also, not inside the same YAML file. You can write service.yaml separately, deployment.yaml separately. No problem. Clear? Still any confusions? Online team? I think whoever asked this question. Nagaraj, you clear? Yeah, perfect. So now this is static approach. Now what is dynamic approach? So let's go here. Okay. See, as we know here, deployment.yaml is there. Service.yaml is there. Many other things also there. Okay. What I can do, I'll just remove anything. So let me check into my GitHub. I will remove few of the not necessary YAML files. So yeah, Kubernetes 9 AM. I have already updated horizontal auto scaling also. So deploy service test. Okay, remaining I can delete. rm-rf ns works ls. Okay, if you can see, first one is what? Deploy.ml. Same deployment.ml only, no difference. vi, same deployment.ml. So you can understand here resources, new one. Okay, new one means, so we are giving request CPU 250 millicore. I mean, this pod can take only 250 millicore. Limitations, resources limitations. For example, guys, in your node, only 1 GB left. Node means your ESOT instance. But if you create a pod, each pod is taking 500 MB, for example. You can create only 2 pods only. And maybe the one pod, it can take 1 GB also. Just I'm saying example. Second pod, there is no space to create. So in the resources, if you use the resources, we can control maximum this pod can take 250 millicore only. Otherwise, it will fail. It will expect more load. You can just throw an error. There is no specifications, kind of limitations. If I give, maybe it will take, there is no limit it will take based on the application required RAM from the node host. If I give 250, it can take only 250. Kind of you can mention the resource block. Okay, not much important, just I'm saying that only. Okay, and remaining, as we know, deployment.ml is the same thing. And in this case, we have written service.ml is separately. But selector is what here? App engine selector. Definitely this selector should be there. Deployment.ml. Otherwise, service will not create. Let's go and check. VA. See. Clear? So now, kubectl. Let me check any pods running. No pods are running. Guys, as we seen the VA deployment.ml, how many replicas will create? Only one. If the demand will be more, still one. Is a static one. Understand? It's not a dynamic. Like in auto scaling group, we have a static approach, dynamic approach. Static always you can change the number 1, 2, 3, 4 so that it will create. But dynamic means depends on which factor? CPU utilization. So we need to say to deployment.ml, you should depends on one more AML. You should follow the instructions from one more AML. That AML is called horizontal pod auto scaling.ml. In that horizontal pod auto scaling AML, give the instructions to deployment.ml. Now change 1 to 2, change 2 to 3, change 3 to 4, change 4 to 5. Whatever, if you mention 1, even though the number will change. Who can change? Either you can change. If you can change, this is a static process. System can change, dynamic process. How the system can change this replica count? Based on horizontal pod auto scaling.ml. So if you want to maintain the dynamic approach in your project, definitely horizontal pod auto scaling.ml you should create. Clear? Okay. So service.ml is common as we know. Deployment.ml common as we know. Then what is the specialty is there in the horizontal pod auto scaling.ml? We can see now. See here. In horizontal pod auto scaling, kind is horizontal pod auto scaler. In deployment.ml, kind is deployment. In service.ml, kind is service. Same horizontal pod auto scaling type is kind is horizontal pod auto scaler. Metadata common for all the pod AMLs. Now specification, here is the matter. In the specifications, if you can see, I'm calling the target. What is the target here? No. This horizontal pod auto scaling call to which AML? Deployment.aml. Why? The replica count will be there in deployment.aml only. So this horizontal pod auto scaling control the deployment.aml by map the target here. See, this is the target of your deployment.aml. Otherwise, you can see here VI deployment.aml. See, name is Nginx HPA, kind is deployment, and label is app Nginx. These three we have given in horizontal pod auto scaling. Again, I will go there. See, kind is deployment, name is Nginx HPA, application app version is apps v1. But if you can see here, there is no label. Horizontal pod auto scaling, not calling service. Horizontal pod auto scaling calling entire deployment. So that we are giving deployment name here. Kind. This is deployment name of the deployment YAML file. Understand? So I'm calling my deployment file. This is the name of the deployment file. If you have a confusion, again, you can go. See, I'm calling entire template of deployment.yaml. That's what I'm giving. Name is Nginx HPA and deployment is deployment, kind is clear. Why? The reason this HPA should call your deployment and give the replicas. In your end, one is there, right? Change to 2, change to 3, change to 4, change to 5. On which factor? And which factor HBA can say to deployment.yaml? CPU utilization. See, the resource is CPU utilization. Same thing, auto scaling group also same thing, right? Based on the CPU utilization, we can change 1 to 2, 3 to 4, something we can give the count. Same here also. The metrics is what? Resource metric is CPU. My load is just only 1% to understand here. So horizontal pod auto scaling saying that I will give the instructions to you. The number is 1 in your end, right? Maybe 2 or 3. So I will give the instructions based on the load. So you just follow. That's what I'm giving the target and is deployment.yaml. Now it is the deployment.yaml is 1, right? At this time, if the load is more until 10, it will support till 10 replicas of your deployment.yaml. The reason is maximum is 10. So in this case, 10 already deployed your pods. Can we expect 11th pod? No. The reason in your HPA.yaml also there is no 11th number, the max count. So simple, I can change the number here otherwise. 11 to 20, no problem. It will wait, it will support till 20. But still, statically, your deployment.yaml count is still 1 only. But dynamically, it will change the count by HPA.yaml. Clear? Any confusions here? Okay. So now, kubectl, apply. What I need to apply now? Service, deployment.yaml, HPA.yaml. So in this case, you can give just -f dot. It will apply for, and inside your directory, all YAML files will be applied. No need to mention each and everything. See, deployment.yaml created, horizontal autoscaling is created, service is created. So now kubectl get pods. Anyone tell me the result? How many pods I can see? Okay. See, 1 only. When the pods number reach to 10, if the load is there only. If the load is there only. Okay. So now, first what I can see now, let me check the service. Service also created, right? How to check the service? SVC. If you can check here, See, load balance is created. This is for this one only. Not for previous one, already deleted. Why? We have deleted deployment and service, so load balance also deleted. So now one load balancer is created. Let's go and hit this one. Refresh. So this is not working, if you can see. So we can do for new load balancer, now created one. So welcome to Nginx. Now, if I hit more, the traffic can increase on your pods. In that case, the horizontal pod auto scaling always monitor your request, CPU utilizations. It can trigger the deployment at ML and create a pods. Clear? So what I can do now, so I can share this ELB URL to you, or I can increase the load on this ELB URL. I have a one script to increase the load on your pods. That script can hit your ELB URL multiple times, increase the load so that we can see the load and we can observe the changes in the pods. Okay. So if you can go for my script is test.sh shell script vi 10,000 requests will go to this load balancer. But this is the old load balancer. What I need to do here? Update the new. So please don't try with the existing one. Maybe the load balancer there or not. I don't know. Still you are checking only one pod will be there. But you need to give your endpoint. Clear? I have given my endpoint. So how to run this script? SHR dot forward slash test.sh. See, requests are going 10,000 requests are going to your load balancer. 2,000, I mean, it is going to hit. So what I can do parallelly, let's close this one. So parallelly, I can open duplicate tab. So easy to user. So now sudo su hyphen. Now you can see the kubectl get pods. See, load is increasing. Now 4. So we have a one concept, guys, metrics configure. In your node, you can install the metrics. For example, what is the command to check your load? You know, top command, top, TOP. Top command will show the load on your server metrics. For example, kubectl. See, I can see the load on each pod. kubectl top pods, kubectl top nodes. Okay. If you want to see the nodes, kubectl top nodes load, I can see CPU 5%, 4%. So how I can configure this metrics? It is not a, it will not come along with the cluster. We need to run one command. That command in yesterday notes, I think I have shared. If not, just see here. So worker loads, services, horizontal pod auto scaling, metric server. So the first command to deploy a metric server, the Kubernetes metric server is aggregator for resources usage data in your cluster and isn't deployed by default. Okay. It will not come under default. What we need to deploy by following the process. We can copy this one. What happened? These many pods will create the background to run the metrics. Okay. So one command only, so that metrics enable. to verify the metric server deployment, so we need to run these commands. So it will run kube system namespace. I will discuss what is namespace. Okay. So after that, you can check the metric server details. Get right command is get right. So kubectl get deployment metric servers -n kube system. So metric server is running in your background. That's what it will help to show you the load on your nodes and pods. Understand? Without this server, we cannot check the top command, just for your information. If you can give the kubectl top pods. Okay, I'll just give kubectl top pods. If you can give, we can see the load on each CPU. Okay, so that we can see here after configure metric server only in your Kubernetes. The only command kubectl apply -metric server, so that background few pods will run related to metrics to collect the metrics for each node and each pod. Okay. Okay, so after some time, definitely it is reached to 1. The reason I have given 10,000 requests, right? So now I'm not giving 10,000 requests, already done. So it is close to reduce to, I think already reduced. Kubectl will get pods. Okay, still is running 10 pods. After some time, it is going to reduce 1. Okay. Any questions? Horizontal pod auto scaling. Okay, I'll do one thing, guys. ls vi hba. So 1 is there, right? I can increase to 90. I mean, each pod can support till 90%, not 1%. No, that's what we can see 1 or 0, 1 or 0, right? The load is 1. So if I give 90, so I can give kubectl apply -f dot also, no problem. Even one change, that change only config remaining is unchanged. No effect. See, if you can see unchanged, only configured what? Deployment.ml and your horizontal pod auto scaling.ml. Now you can check now. See, reduce the pods count, right? 10 to 4. After some time, it is close to 1. Why? The pods are supporting 90% load now. Reduced already. I think it will take some time. Okay, just we can observe parallelly for this also. After some time, we can verify it is close to 1. Okay. Any questions on this? How to configure origin pod auto scaling? So if any project, if you want to make it like a dynamic process, definitely we need to configure hpa.aml to call your deployment.aml. Okay. So Kubernetes is not a easy tool, multiple configurations. So if you know AWS concept, this is very easy. If you don't know AWS concepts, very difficult. What is load balancer? What is auto scaling group? How it can communicate? These many things we need to understand. So far is easy, right? So far is easy, right? Difficult things are there. But to configure your project, fine. Okay, just deployment run means pod will run, your project will run. That's it. Okay, so what you need to do, your work is for today. You have already pushed some ECR images into ECR, right? 4 or 5 something, I think so. 3 or 4 projects. That ECR images you can give in your deployment.ml. Understand? What you need to do? Just go to Guys, you are not a freshers now. Okay. I'm not treating like a freshers. You have done already close to 4 months. Sir, how to give easier path? That days already gone. Okay. So if you have any questions, simply you can go for chat GPT. You can ask them. See, whatever name you have given for easier repository, click on that name. The image we can see, give the URL of image, copy paste, give into your image session only. Run it. Your application will run. How to check the service? You need to configure service for the deployment.ml, node port or load balancer. Check by using load balancer URL. Check by using node port. You are able to access your application, which is there in your ECR image repository. Clear? Done. This is a process. Now, the next, our next task is configure with Jenkins. What you need to do? Run kubectl apply if1f deployment.ml only in the one more stage after Docker. Understand? After Docker, you need to give in the deployment.ml already ECR image path, right? No need to specify anything in the Jenkins. Directly in the Jenkins, in the last stage, you can give sh kubectl apply -f your deployment.ml name. The deployment.ml you should update into your GitHub. First stage, clone. Next stage, Docker build. Next stage, image push to ECR. Next stage, deploy that image into Kubernetes. Clear? That you need to do. Okay. I will show you with Argo CD. If required, I will show you Jenkins also. There is no matter, just 5 minutes only. But I need from your end practice. Okay, already Jenkins we configure multiple with Docker, with whatever we have done so many things, right? Yeah. So we have a time for 10 minutes. So what I can do now? So I will show you what is namespace here. Namespace is very easy process. Namespace is nothing but, guys, kubectl create namespace test. So one namespace is created, test. I can deploy pod in this namespace. Understand? So how to deploy? So in my end, okay, I'll just come to day 3 or ls cd day 2 ls. So my pod.ml is there, right? Just I can apply only pod.ml. kubectl apply -f pod.ml. Again, I'm giving -n namespace. What is my namespace? Test. Pod created, right? What is the command to check? Why am I unable to see that pod? It's a different namespace create, not default namespace. kubectl get pods -n test. So now we can see this pod. Pod is running different namespace, not in your default namespace. So you can handle like this way, or you can define to create a namespace in YAML file also. So I will show you the example. Okay, let's go to there. See namespace. See what you can understand. Same, whatever I have done now by using command, just going through the YAML approach. What is this? Creation of namespace. What is this? Creation of pod. That's it. So it will use one more label is there, namespace equal to demo. The demo already created by using this block. Understand? So Control C. So no need to create manually any workspace now in this time. So simply vi, so ns.aml. So if in this case, what is my namespace name here? demo. My pod is running on demo namespace. How you configure? I just given here one more extra label. Take that namespace demo. Or this namespace you can create by using command. In your pod, you can give that namespace. We have created test namespace kubectl create namespace test, right? If this pod want to run on the test namespace, you can give here namespace test, or while running time kubectl apply -f pod.ml and -n, you can give the namespace. That is the second approach. This is the approach is very easy. No need to create anything manually. Run this, namespace will create and map the namespace of this pod also. Understand? So kubectl apply -f ns.ml. No need to specify -n, right? That is there in your YAML file only. So first we'll create namespace. Then pod.yaml create in the same namespace by mapping the labels of namespace equal to demo. Now kubectl get pods. Again we can see my pods are one only. Remove all the 9 pods. In horizontal pod auto scaling, I'm saying that, whatever. Now kubectl, how to check the pod in specific namespace? Demo, right? See, like that we need to. If you want to delete, definitely we should give namespace. Otherwise, it can say there is no resource and name of my app. Deleted. Clear, guys? So this is the namespace, horizontal pod auto scaling, worker nodes, service.mls. Okay, and metric configuration also. I think yesterday notes there is a metric server also have shared. You can go and check. Better to. So any questions? So nodes also done and your GitHub also ready till namespace. Just clone, practice day 1 to day 4. Okay. So tomorrow I will start schedulers. Very important. It will take one class completely for schedulers. Okay, guys. Then bye.